Welcome everyone, and my name is Deval. I'm the product manager with QNAP, and I'm joined with Daniel.
Yep, and I am Daniel, Technical Account Manager at QNAP.
All right, so and then thank you all for joining our webinar. And today we'll be going through our setup with network and virtual switch and what you can actually do with network and virtual switch, some advanced configuration, and some setup tutorials that we can go through using the network and virtual switch. Network and virtual switch is actually a really a really good software that we provide with the QNAP's hardware that you can actually create like a virtual switch with the QNAP that you can then connect your containers, your virtual machines, and you can actually create a complex set of networking within the QNAP itself by using just the two physical ports. Or you can actually don't need to actually even connect the two physical ports. You can actually just have just a virtual switch, basically a dumb switch or smart switch inside the QNAP. So from now on, Daniel will take over and he'll continue the presentation. Thank you all.
Yeah, thank you all for attending. For our agenda today, we're going to talk about what is a virtual switch, four virtual switch modes, NAT, bridge mode, external only, isolated, the benefits of each mode, some use cases, and I'm going to show each mode on the Office NAS. So first of all, what is a virtual switch? It might at first sound a little bit complicated, but if you just think of it the same way you think of a physical switch, it's really not complicated. It works almost exactly the same as a physical switch. I think just about everybody could understand how a physical switch works. So here, physical switch has physical ports. Devices plug their Ethernet port into physical ports. And anything that's connected to the switch can connect to other devices on the switch. This computer can connect to that computer. This computer can connect to that computer. All these computers can connect to the router, and then devices on your office or home through the router Wi-Fi can connect to the router, from the router through the switch, connect to any of these devices. And these devices through the router can connect to the internet. You can set up remote access. And the part of the physical switch is it just has a bunch of ports devices connect to, and it connects all the devices together through the switch. So it's not too complicated of an idea. And a virtual switch is really not very different. But some of the main differences is physical switches connect to physical devices, virtual switches connect to virtual devices, containers, and VMs. And then one other difference is because virtual switches don't have a physical Ethernet port. To get the virtual switch connected to your router, you need to connect the virtual switch to your Ethernet port and then connect your Ethernet port to the router. So the one main difference here is this is just this extra step of virtual switch to NAS Ethernet port to router, whereas a physical switch goes directly to the router. But aside from that, it really works essentially the same way. Or you could connect your NAS Ethernet port to a physical switch, and that physical switch could be connected to the router. So if you want to understand how this works, it's really almost exactly the same as if you had two physical switches connected to each other. If two physical switches were connected to each other, maybe this port would connect to a port on the physical switch. But because this is a virtual switch with no physical ports, this connects to the NAS Ethernet port and the NAS Ethernet port to this physical switch. But otherwise, it works essentially the same as two physical switches connected to each other. What that means is this computer can connect to this computer could connect to this VM could connect to that computer, this VM could connect to that container. These containers, VMs, can connect from this switch to the router. Because they connect from the switch to the router, they can get access to the internet. Devices on your home Wi-Fi can Wi-Fi connect to the router, from the router connect to this device, from the router connect to these devices. So it really works essentially the same as if it were just two physical switches connected to each other. The main difference is you first bridge it to the NAS Ethernet port, and then after that, it really works basically the same as a physical switch, at least in bridge mode. I will talk about some other modes as well that maybe work a little bit differently, but at least in bridge mode, it works almost exactly the same as a physical switch. And if you think of it the same as a physical switch, I think it's pretty easy to understand. So some different modes I do want to talk about today though, because there is more than just bridge mode. There is isolated mode, and that's essentially where you do not connect the virtual switch to your NAS Ethernet port. You do not let the virtual switch connect to your NAS storage. and therefore the VMs or containers in that virtual switch have no access to the outside world, no access to your NAS storage or anything. You can't even ping these VMs. They are just not accessible. This isn't useful very often, but if you want to know what this might be for, the very first webinar I ever did involved showing how to recover from the WannaCry ransomware using snapshots, how to get your data back. And I had WannaCry ransomware on a Windows VM, and I kept that VM on an isolated network because I did not want to give the WannaCry virus access to the QNAP office. So um, that's the one case I found a use for isolated network, but in most cases, you probably won't use this. External only, the virtual switch is connected to your NAS Ethernet port. But what makes it different than bridge mode is these VMs are forbidden from going internally to your NAS storage. So if the VM wants to transfer a file to your NAS storage, you actually have to go like externally to like a physical switch and then back to your NAS storage. Bridge mode, virtual switch connects to your NAS Ethernet port, but we also allow like VMs or containers in the virtual switch to internally transmit data to your NAS so that you can internally transmit data faster than your Ethernet connection. And then I didn't put it here, but NAT mode I'll also talk about. NAT mode, it at first looks a lot like isolated mode, except we set up network access translation so you can actually forward data from here to your Ethernet ports through network access translation. So network NAT mode would at first look like isolated mode, but adding network access translation actually does allow the VMs and containers to connect to the outside world through network access translation. And I'll make it more clear what that is when actually going to the NAS. But first of all, isolated mode, you got your virtual switch, but it's not connected to the NAS Ethernet port. It's forbidden from internally going to your NAS storage. So there's no way to get data from here to your NAS Ethernet port, no way to get data from here to there, no way to get data from here to your router. These are all isolated. Now, this container could connect to that VM might connect to that VM, but these containers and VMs cannot get to the outside world. If you try to type the IP address and ping them, you'll get nothing. You try to transmit data, you cannot transmit data. Now, from Virtualization Station, you could control and access this VM from Virtualization Station to manage the GUI, configure settings, but you cannot transmit data. So it's a way of keeping things really isolated if you really want to make sure that no data from here gets to the outside world. And you almost never use that, but the one case I used that was when I had a virus in a VM to show how to recover data using snapshots from a virus. But other than that, you probably won't use this. External only mode, the switch does bridge to your Ethernet port. So because this bridges to your Ethernet port, data can go from here to here. You can transmit, you can do you can transmit files and folders from here to there, here to there. You could map through SMB from computer to your VM, for example, that'd be just fine. If you want to get to your NAS storage, you can go from here to your switch, from the switch actually back to your NAS through the Ethernet, but you're forbidden from going internally. So if you have an older NAS with just gigabit Ethernet, you can go from here, transmit data to your NAS at gigabit speeds, but you can't go internally. The advantage of internally is you're not limited by the speed of your network connection. So if you had gigabit Ethernet, rather than be limited by gigabit speed, you go internally the speed of your actual storage. But in external only mode, you're forbidden from internally, you only go through the network. But these can connect to these connect to the outside world. Devices on your router's Wi-Fi can get here. It just forbids the internal transfer. So bridge mode, more or less same thing, except you can go internally to your NAS volume. So if you want to map a network drive from a Windows VM to NAS volumes, you can do transfers at faster than your network speed because you can go internally. So with these different modes, you can then set up your network with your physical devices on your network, your virtual devices on your network, and you can just decide what kind of access you want to give your virtual devices. If you want them isolated, if you want them to show up on your network the same as a physical device would, you can just do bridge mode. But there's more isolated modes or NAT modes where they don't show up the same as a physical device. So a possible use case, maybe you want to run like pfSense or some firewall software as a VM. So in this case, you might use bridge mode to give your firewall the same access to your network as a physical device would, because some people might choose a physical device for their firewall, or they might choose a physical device for the VPN device. And in bridge mode, you can give that virtual device the same access to your network as a physical device, and you can make it show up on your network really the same as if it were a physical device. So that's great for like a firewall or VPN or something. But another use case is to containerize certain applications, particularly rather than run a local app on your NAS, you can containerize it instead, particularly if these are applications you want to forward ports to for remote access. So I often suggest don't forward any ports to your NAS if at all possible. And I mean, now if you run QVPN, want to run forward the VPN port, that's usually just fine. But some of these other services like Plex, if you do have the option to run the Plex app, forward the Plex port to your NAS IP. But if you want to take security to the next level, you can run a Plex container and then forward the port to the Plex container IP. Or for example, if you want to host a website, you could just do more direct NAS hosting, but the other option is run like a container of WordPress. And in bridge mode, each container has their own IP address that's different from the NAS. So in this one, you can see the Plex IP address. It's not the same IP address of the NAS. So for the Plex IP to this IP address, and that way you can remotely access your Plex, but no ports are forwarded to your NAS. Also, the advantage of containers is they can be very isolated privileges. So what I have set up on this NAS is Plex is running, but it just has read-write access to a little config folder, and it has read-only access to my multimedia folder. So that means even if somehow a Plex container were to somehow get compromised, the container only has read-only access to my media folder. So with that kind of very isolated access, you're much less vulnerable. It's take security to the next level to containerize apps, because containers are isolated. You can greatly limit the privileges of the container. And if ever you have to forward ports, you can forward ports to a different IP, not the IP of your NAS. And the same for WordPress. So you typically buy a domain name for your website. Then you need to have that domain name forward to the IP of your WordPress. So rather than forward to the IP of my NAS, I forward to this IP. And then you can also do other things in container like zero-tier VPN. Some people use that. A lot of people like Tailscale instead. That works fine too. QVPN also works fine, but just there's different things you can do through containerized applications. And then with Network and Virtual Switch, with your different apps and VMs, you could set up like Ubuntu, you could set up WordPress, you could set up Plex, you could set up Windows VMs. You give each container or VM the kind of access that you want it to have. So this is more or less what it looks like, but what I'm going to do now is actually go onto my NAS. To show off Network and Virtual Switch. So from here, you can kind of see what it looks like. Let me zoom a little bit. I feel I'm going to zoom out. I can see a little better. All right. So from here, you can see I got my VMs and containers over here. I have my virtual switches over here, and I have my NAS Ethernet ports over here. Also, this is a Thunderbolt NAS to the Thunderbolt ports as well. We use Thunderbolt as if it were Ethernet. We send network signals through Thunderbolt, same as we would through Ethernet ports. So all the network ports show up here, physical network ports, virtual switches, VMs, and containers. And you can see really quick which VMs and containers are connected to what virtual switch, and which virtual switches are bridged to which containers. We can also see which like VMs or containers are on or off. So gray is off, blue is on. And we can also see, you can see here like virtual switch 1 is bridged to adapter 2. Virtual switch 8 is bridged to adapter 1, but right now on this NAS, adapter 2 is actually connected to my Office switch so that you can actually send data through adapter 2, but adapter 1 is not connected right now. And that's why that is gray. And you see the symbol here because that's connected. There's no symbol here because that's not connected. So you can see pretty much all the information you need to see here. You can see a lot of information here really quick. So first of all, I want to point out some things. Because virtual switch 1 is bridged to adapter 1, that means the Office router has a direct access to adapter 2. The Office router has direct access to adapter 2. Adapter 2 has direct access to the switch, and that means the Office router has direct access to each of these VMs and containers. So the Office router can do DHCP, and that's why you might notice that the Office router gave my NAS this IP 10.15.140.77. The virtual switch has the same IP as my NAS IP. And you might notice that these containers and VMs have an IP on the same subnet. So 10.15.140, 10.15.140, 10.15.140, all the same subnet, just the last number that's different. And that's because the Office router is doing DHCP. The Office router is assigning an IP address to each VM and container on that switch because the Office router has a direct line to every VM and container because it is bridged. So this is the most straightforward, easy to understand. Let's actually look at the settings here. So to bridge a switch to an Ethernet port, you just click which Ethernet port you want to bridge to. So I've clicked that, so it's bridged to adapter 2. Very simple, very straightforward. You can see here which containers and VMs are connected to this virtual switch. I could add or remove as I see fit. So over here, everything is DHCP client. So the switch and the devices on the switch are a client of the Office router. The Office router is doing DHCP. So everything on this switch is a client of the Office router DHCP server. So I don't need a static IP. Office router is doing DHCP. So I'm not enabling NAT. You do not need network access translation when you have a direct line. Network access translation is needed to move from one subnet to another subnet, but everything's the same subnet because there's a direct line from router to Ethernet port, a direct line from Ethernet port to switch, direct line from switch to VMs and containers. So network access translation is not needed. Everything's the same subnet. No translation needed. And the switch does not need to be a DHCP server because the Office router is DHCP server. And so this should definitely be off because you do not want two DHCP servers on your network like that. You don't want two competing DHCP servers. That could cause all kinds of problems. So you do not want this. You do not need this. The Office router is DHCP server. So you can have IPv6 available or not. You can do automatic DNS or manual DNS. And I don't want to change any settings right now, so just leave that. So that was virtual switch 1. Bridge mode, very simple to understand. But let's go to a virtual switch that is NAT mode. So here you can see it's not bridged to any adapter. So there's no direct line to any adapter, but because it's NAT mode, it's not isolated. So the VMs and containers, or just in this case, just the containers connected here, do have access to the outside world, but through NAT. It's not a direct bridge. So because it's not a direct bridge, the Office router is not going to assign IP addresses. So you assign a static IP address to the virtual switch. So that's the IP address of the virtual switch, a subnet mask, because the Office router is not going to do that for you. And of course, it's not a DHCP client because the Office router is not going to do that. We enable NAT because it's not a direct line to the Ethernet port. the only way to let the containers have access to the outside world is network access translation. If I were not to enable this, then this would be isolated. If I were to turn off NAT, then there would be no access from the containers to the outside world. There'd be no way of pinging the containers. You would not be able to ping them. You would not be able to transmit data to them. They would be isolated if I did not enable network access translation. Now, on a lot of switches, you might enable DHCP server. If you want the switch to assign IP addresses to each container, you would enable this. But because this is not enabled on this switch, you have to manually assign the IP address to each container in this case. And you could choose a DNS or manual DNS. In this case, there's no DNS set, so these containers may have a little trouble like accessing the world of the internet, but you might actually prefer it that way for a lot of containers, depends what you're doing. And I want to show this last container here. It's very similar. This is another NAT container. Again, not bridged to an adapter. You choose what containers are connected to it. Again, static IP. But this one has NAT enabled and DHCP enabled. So the switch itself is a DHCP server. So the switch itself can assign an IP address to each container. And you choose the starting IP address. It will assign IP addresses between this address and that address. So it's pretty much the same as the last switch I showed, except this can actually assign IP addresses to your containers. You don't have to manually assign the IP addresses. Other than that, it's about the same. So I don't currently have anything set isolated mode because I don't really find isolated mode that useful in most cases, but you could assign isolated mode. And I've found that bridge mode is what I use the most often, but there are uses for NAT mode as well. Now, just to show how I'm doing this, what I have in like NAT mode, what I have in bridge mode, here's some things I set up. So as you see, the NAS 10.51.40.77, but I did set up a WordPress container. And notice it's a different IP from the NAS 10.15.140.47. So if I were to buy a domain name, I would then have that domain name go to my global IP, and then I would forward that to this IP address with a 47, not that IP address. So a more secure way of hosting a website. I have my Plex container. So again, that's the Plex port that I might choose to forward for remote access to Plex, but as you see, it ends in 16, so I'm not forwarding the Plex port to this. I'm forwarding the Plex, I could forward the Plex port to that. And so these are both in bridge mode, and that's why they have their own IP address separate from the NAS. But I have something else in NAT mode. I have a little Ubuntu container in NAT mode. And because it's in NAT mode, you actually access it through the NAS. So you see this is the NAS IP. But if you type in the NAS IP and this port, it will forward to the container. And so what this is more useful for is if you don't want this Ubuntu container to just be as visible on your network, like if you do a LAN scan on your home or office network, you're probably not going to see this. It's not as readily available on your network, but you can still be used for things. For example, if I want to SSH into my NAS, this can be useful. Like if I'm at work, but I want to SSH to my home NAS, I could just Q-link to my NAS, open up this, SSH to my home NAS. Or if I need to adjust my home router settings, but I'm at work, from here I can open up a browser and locally access my home router. So this could be useful, like if you're maybe you're using QVPN, but you messed something up, you need to troubleshoot it. You need to adjust your router settings, adjust your router firewall, or forward like the VPN port. So this could let me troubleshoot my QVPN by directly logging into my router from a local browser. So for something like this, I don't really need bridge mode because I may not want this to be as just visible on my network. So NAT mode also has its advantages. So this is what I'm doing right now. And we have many other containers as well, but I didn't want to go through all of them. But I'm using NAT mode here. I'm using bridge mode here. And that is more or less what I wanted to show, but just a few other things in Network Virtual Switch. You can directly see your adapters there. And I guess a few more things I could show on the virtual switch. And well, I think that's enough for now, but like for an adapter, you could like directly adjust settings, like set like a static IP, things like that. Um, but yeah, that was the main thing I wanted to show is how to use the virtual switch to give access to containers and VMs. And I want to ask right now, are there any questions?
All right, looks like there are a few questions. Caesar has a question about do they use DHCP just like a Hyper-V? So, if I understand this correctly, if I you may have to elaborate on that question, Caesar. So on the QNAP, you can actually create a virtual switch with DHCP and then have the VMs connected to that virtual switch, and they can all receive uh, the DHCP. So it looks like he did provide that information. So um, but I think Caesar updated the question. Says like you answered your DHCP question, so that's great. But he added NIC speed. Can you elaborate on the NIC speed part of it, Caesar? Another question is the OS that you're running on the demo. I think it's on QTS Hero. Is that correct, Daniel?
Yeah,
But yes, even if it's QTS Hero, both the operating system has similar feature sets regarding virtual switch. The virtual switch part does not change depending upon the operating system. So whatever Daniel showed here is all available on both operating systems. So you don't have to worry about that. You have another question saying that um, how much resources that virtual switch uses. Virtual switch is actually a part of the operating system. It does not use actually we haven't seen much of resources used with when using virtual switch. Um, so I would say minimal, not even like few percent of CPU usage. So there should not be any kind of hit on the virtual switch part when using virtual switch. There's no system resources. What are the speeds of on the virtual switch and physical cards? So actually, they are hardware accelerated. So these, when at least the internal part, so whatever speeds of the network card you have, you'll be getting the same speeds over the virtual switch. But the speed also depends upon the QNAP's NAS's resources as well as the CPU processing power as well. So if it's an Intel Celeron processor and you're running a VM on that, uh, I think that will be the bottleneck more than the virtual switch part. But if you have a good enough processor, like I have an i7 processor, even Daniel's running on an i7 processor, I'm able to get the 2.5G speeds or even 10G speed sometimes if I have a 10G card connected. So it should be okay depending on a lot of factors. Another question is, what exactly does the option with spanning tree? What are the advantages and disadvantages of that? Um, So spanning tree on the QNAP, you may have to. It's like a protocol that um, I may have to. Actually, I'm gonna actually answer that offline. So give me 1 minute.
what are the key differences with IBM storage solutions?
But with compared to IBM solid storage solutions, that there are a few key differences that I can say. We are more affordable as with compared to IBM storage solutions when it comes to the NAS, the storage part of it. Also, uh, we have devices available from all the way from like 2 bay all the way to 30 bay units. So we cater to a lot of different use cases as well as a lot of different customer base as well, starting from home solutions all the way to enterprise solutions. Our learning curve for storage solutions is very easy as well compared to other solutions out there. Um, and then the storage part, you can add additional capabilities with our App Center. That's another major advantage compared to other solutions as well. You can add virtualization within the QNAP itself. You can add, surveillance solution by adding another application on the QNAP. So we're really flexible on what we can do when it comes to the storage solution part of it. So I would say those are the key differences between IBM solution and QNAP solution, or it doesn't compares to other solutions, storage solutions as well. Can you use virtual switch to tie some IP cameras to a drive for storage? And you want to take that question?
Use virtual, can I use virtual switch to tie IP cameras? Can you say that one more time?
Yeah, can you use the virtual switch to tie some IP cameras to a drive for storage?
Well, I mean, like we're running Milestone right now, like a VM. So I mean, you could run Milestone NVR as a VM, and then you could bridge it. You could bridge it to a switch, and you
Yeah,
could connect
so
to the switch and bridge the switch.
yeah, to elaborate that, yes, you can actually, so if you, so we have different solutions. We have storage solution that we have QVR Pro solution, right? The QVR Pro that you can install an application on the QNAP, and then run your own application. And then you can create, because most of our QNAPs comes with multiple network ports, you can actually have one dedicated network port with its own virtual switch. You can also enable DHCP if you need that on that, and make sure that it's not connected to the main network, and have that connected to to a physical switch that is connected to all the cameras. So the camera network is separate than the main physical network. And the other network port on the QNAP will be connected to the main network. The QVR Pro software will be able to see both the ports on the QNAP. So the QVR Pro can record the cameras from the NIC2, and then if somebody wants to look at the camera, like you want to look at your camera, or like another person wants to look at the camera, the QVR Pro can broadcast the data using NIC1 to be able to look at all the cameras. So the advantage of having this setup is your main network does not block down with all the data coming from the camera. So that's the first most common use case that we have with QNAP surveillance solution. We also have another solution where if you have Milestone or Genetec or Exact software, you can actually virtualize that. So you can create a VM that's on the QNAP, uh, and then we can run that, and it can create its own virtual switch with all the cameras as well on that same virtual switch, and everything is all, and Milestone will be able to record and connect that, and you can actually access the data using the virtual switch part of it as well. So yeah, that's another solution that we can offer with QNAP. Could I host a VDI in real time? You said depending on the CPU and RAM and number of Ethernet cards, but you could talk about implementing this as a service solution. That's a good question. So VDI is in virtual desktop, is that correct? I think I believe that's what you're referring to. I'm gonna have to think about this. As so as an MSP, you want to sell this as a solution. I think what you're referring to. I may need to. I'm not able to come up with an answer on top of my head, but Caesar, I'll put my email address. We can talk about this offline. So I may need to come up with a solution that we can use this as a service. That's a good question.
Yeah, so not to answer the question exactly, but I mean, of course, with like a VM, like a Windows VM, you could set up remote desktop, but making it a service is a harder part. So yeah, not ready to answer that question, but with a VM, you can do it on a QNAP VM on a QNAP, you can do about the same as you could do on another VM. So Windows Remote Desktop would work just fine for accessing, but using as a service is more tricky. As MSP, can I sell this solution? Well, I
He's
mean, you
talking
can
about the
definitely
VDI.
sell.
So yeah, I may need to think about this, Caesar. Hopefully, um, and then yeah, I will need to actually think about this. All right, looks like no further questions. So thank you again, everyone, for joining our webinar. We really appreciate that. And also, we'll have another session, another webinar next month. We usually do monthly. So we'll have another webinar next month. You will receive an email shortly about that. We'll also receive an email shortly about this particular webinar with an email link or with a YouTube link to play back if you want it, if you missed something. Um, so you can play back again. So, but again, thank you all for joining, and you guys have a great day.